Hello there. Alright, let's check to see if it came up. Checking on my phone real quick. See if I can get to it from another device.
Admiring the deforestation here.
Mm-hmm.
There's so much room now that there's not a quadrillion trees that I planted.
Yeah.
Hey man, I'm gonna do what nature would want me to do and turn them into carbon.
Indeed.
Literally the only reason I got spruce was so I can make railings, and I have like 6 stacks of 64 spruce logs, so...
Alright, we are streaming. I can see
yeah.
it on my phone. We're good to go.
Neat.
Do you have me? Or are you following me on Twitch yet?
Oh yeah, let me open you.
Yeah.
Proceed.
Let me fly down to you. Da-da-da.
And now watching on my telephone. Hey mom.
Hey, look, I'm famous.
Oh my. Yeah. I have a stream. I'm on a stream that has 1 view, and I'm it. Forgot to do that.
Alright, you wanted to talk over a topic.
Yep.
What is our topic?
So, the topic is going to be abiogenesis and why it is relevant to evolution, because a lot of people that believe evolution is the way of things don't seem to also believe that abiogenesis plays a part in it.
In what was it called?
So abiogenesis,
Abiogenesis.
if you put all of the pieces together, abio, like abiotic or antibiotic, is non-living, and genesis means beginning. So it's kind of like at some point, if there are living things now, and the earth didn't always exist, there must have been a point in which living things also didn't exist. And so you have to therefore come to the conclusion that there must have been an unliving thing that resulted in a living thing.
I see, so that's the dust to life portion of the evolution. So the
Yes.
particles to protein to living organism.
Supposedly. I didn't realize my axe had silk touch. Wait, what?
You have silk touch on your axe. Nice.
No, I'm confused. I have leaves in my inventory, but I don't have anything but the pickaxe that uses silk touch. I don't think I used the pickaxe for that. That's okay.
Oh, it might be a woodcutting level on the server. What woodcutting level are you?
75. I'm not even really that high.
Yeah. We're just cutting down a forest. Alright, so continue.
Okay, so the problem with evolution with abiogenesis is that the events that we're supposed to believe that take place are incredibly improbable. And these are not incredibly improbable like the chances of your cousin and what, or your son-in-law finishing college or whatever it is. It's improbable as in it is statistically impossible with
If we
a
want to,
pretty firm...
let's cover some of the statistical probabilities on that happening. So, for example, what's the total number of particles in the universe argument that is quite often used?
So a lot of the numbers are pretty large, and so to give people an idea on the kind of size of numbers that we're talking about, it is a commonly held idea that there are 10 to the 80, that is 10 to the power of 80, 10 times itself 80 times, or I believe that would be 10 followed by 80 zeros, just to put the nail on the head there, or really nail on that idea. And that is the number of elementary particles in the universe. That is all of the hydrogen, carbon, helium, what you may have it in the universe. So that is a good way you can compare fairly large numbers to fairly large numbers.
I see. So 10 to the 80 roughly for particles in the universe, and then for example another probability is the formation of a protein, which goes somewhere along 10 to the 450 if I'm remembering correctly, right?
So a little shy, but the numbers after 10 to the 240 don't really matter much. But the chance of a, I can have to look back, but I think it's a 140 or 160 monomer chain. So that is, a monomer is a basic unit, and you have 140 of them all in series. Each single monomer likes to bond in 6 locations. So if you add up all the statistical probabilities, them all being not only left hand, but all of them forming with the compounds that you want and the compounds existing in the first place, to have the smallest known functional protein, the chance of it developing by itself is 1 in 10 to the 14,000.
14,000. That's quite a
And again,
insane
not just an
number.
yeah, and it's not just an arbitrary number that people throw around because it sounds really big and scary. Again, it's a series of calculations that you can do yourself if you look up all of the individual probabilities of these things happening on their own.
Indeed. What kind of books are you getting these numbers from, or
Mm-hmm.
references from people? Like you can't really trust us
Yeah,
playing Minecraft here. So
yeah, sure.
what kind of data are you getting this from?
So a lot of the data that I will get my stuff from is actually a fellow by the name of Stephen Meyer. And he has his own YouTube channel, which is arguably much more worthy of anybody subscribing to than ours. So I'd recommend, if you're curious about this sort of thing, to check him out. And also he has books, and if you're like me and a college student, you're broke. I bought them on thriftbooks.com, where you can buy pretty much any book. We're not sponsored, obviously. But you can buy pretty much any book for a third of the cost you can find it pretty much anywhere else. So it's not like books are unobtainably expensive or even inconveniently expensive. I literally got a 400-page book on military history for like $4.70, a hardback. But yeah, Stephen Meyer, he's really great. The other guy I have books from is Rob Sandler. He has a book called The Scientific Approach to Evolution. And I think there is probably no reason that the arguments he presents in an unbiased sense, right? I'm not even talking from a Christian standpoint, I'm talking from a scientific standpoint. There is arguably no reason that the average, whatever, American, Chinese, whoever, person hasn't seen these arguments before. Because a lot of the points he makes and his book, again, the scientific approach to evolution, is that evolution is taught as more than it really is, and it belittles or rather degrades the quality of science that people have done, and how much they've had to sacrifice or how much they've lost, even in some cases like Marie Curie. They've sacrificed many years of their life for a science that is being belittled and degraded by the evolution argument, because the science is just more wonderful and more wondrous than it seems a lot of people are willing to admit. But yes, Stephen Meyer and Robert Sandler are very good sources if you're seeking to find these statistics or even just decent arguments, not even against evolution, but just that seek more proper, open discovery and solemn answering of results and that kind of thing.
Yeah, yeah. They're the science. They do a lot of the science stuff behind our conversations. And you've
And
done
go ahead.
significantly more reading into those more scientific sides, while I've done more usually into the more theology side a little bit.
Yep. Yep.
Um, so it kind of evens it out a little bit about like what all we know. Again, we don't claim to be experts. We'll point you towards the experts.
Yeah. I'm just smart enough to know who the smart people are.
Same.
Another guy I will not fail to mention is James Tour. He's another fella that has a YouTube channel that if anybody is itching for a subscribe button, should definitely release their subscribe addiction there. He is also another really great Christian scientist, and he just talks about a lot of topics in a way that I feel maybe even the average person can understand, and some very complex topics, such as organic chemistry, things that you wish that you could delete from your memory, then become almost pleasant to learn with James Stewart.
Yeah. A really good source for geology stuff is the Genesis theory. Is Genesis history? My bad.
Yeah.
YouTube channel. They have a really great selection of professionals who have done amazing research in the area of geology and a lot of history with, for example, the flood, as well as the formation of land.
Yeah. And if you're really trying to get way further in depth in paleontology, going kind of the same direction, Stephen Meyer and his book Darwin's Doubt are probably, in my humble opinion, the best place to seek answers or even to seek questions. Because sometimes it's not just hard to articulate the questions that we have as Christians, but it's also hard to articulate the reasons that we have these questions. And I think Stephen Meyer has a lot of really good analogies that help put things in comparison.
And one thing I feel like we're missing these days is a lot of the doubting and more investigation into the faith. So a lot of
Yeah.
people are so scared of doubting things that they miss the whole like first century believers way of doing things of I have this doubt, can you shed light on it, let's investigate it, let's et cetera, et cetera. Where doubting wasn't necessarily a bad thing, or looking up more details and more information.
Yeah.
I'm hearing something attack something above me. Give me a second.
That's probably not.
Oh, is it you up there?
No.
Distracted by the Minecraft playing. Oh well. I don't know what the sound is. I may ignore the sound. All right. I think back to our topic of the a something or other. Wow, I'm bad at
Oh,
remembering these.
abiogenesis.
Yes. Abiogenesis.
How is there a zombie over here? Must be a dark spot. Yeah, literally, I witnessed the zombie spawn. That would be where the dark spot is. Oh, I got his armor. It's a golden chest plate with unbreaking. Neat.
Switch over and get some cobblestone here.
And I'm going to explain this in a couple of different ways because some people like to think mathematically and some people would rather climb in a hole and die. So I explain it in many different ways. So in the world of mathematics, there is a concept called the intermittent value theory. Now, before you scream and click away, the intermittent value theory is only calculus 1. It's not really complex math. And
And for those
what the
of you who
intermittent
have heard calculus scary, it's not as bad as it sounds.
calculus just is the start of math that requires you to think before you can understand. So, like algebra is relatively obvious because it's just the first time you're seeing variables, x, y, and stuff like that. Whereas calculus is the first time you're seeing new ideas, like a derivative. People don't instantaneously understand that a derivative is something they see in the everyday, but it is. Because you don't just go in your car and travel 6 miles. No, you traveled 6 miles at an average of 30 miles an hour.
Okay. Back to what you were saying just a second ago.
Yep.
For
So the intermittent value theory is a way of determining if a derivative passes through a certain point. Now, because it's not entirely important to understand why the derivative part matters, I can still talk about this and explain why this theory is pretty smart and what it seeks to do. So without talking about derivatives, imagine you have a graph, and you want to know if this graph passes through a point, we'll say 4. But this graph is this graph goes everywhere. This graph goes up to 10,000 and down to negative 10 trillion. And it is not doing so in any meaningful way. It's just bouncing up and down, and this graph
so
gives
is
you a
it like a
headache.
scatter plot, or is it more of like a line graph where it's going up and down and up and down?
So it must be continuous. That means you must be able to draw the line without releasing your pencil or without dropping the chalk.
Let's see.
And with this continuous function, you want to decide if, like I said, if it passes through a specific point. But the graph is so complicated that if you were to try to plug in an x value into the 16 polynomial long equation, it would take you nothing short of a millennia to come up with an answer that is anywhere close to 4. So how you can do it is you can actually calculate the minimums and the maximums of that function. And what that allows you to do is, let me get my water buckets back out. It allows you to see that, my graph has a minimum of negative 10, or whatever it may be. And my, so let me slow down. Because this does matter in this particular, what the heck? I just magically lost all of my water buckets. That was funny. You're trying to find out, if this graph has a value, an intermittent value between a given pair of points. Like you want to find out if it equals something equals y equals 4 if it ever crosses that line. So you find where the derivative equals 0. So where the derivative equals 0 is where the line has a minimum or a maximum. Because the slope is 0, the line must either then continue to go up or down in a continuous function with several polynomials. And whenever you calculate that it has a minimum located at y equals negative 4 or x equals 4, and then you plug in that number into your equation to find out what y is at x equals 4. But if it is y equals 4 and, or let me put it this way, y equals 0 and y equals 10, you know if it's a continuous function because you're trying to seek a function that passes through the value 4, that if the function, being continuous, passes through both 0 and 10, then it must at some point have passed 4.
So on its
Now,
way, so to make it English for people, so on its
yeah,
way from 0 to 10, it must pass through 4 as a continuous line. So at some
and
point, it will pass through 4 on the line.
because you've predefined this function to be continuous,
Mm-hmm.
it is a default must be kind of thing. And the reason that I explain this when talking about abiogenesis is because similarly, we know that that point must exist where the graph crosses over 4 because we know that there is a point that exists before and after. Similarly, with abiogenesis, we know that it is relevant to evolution as it stands currently because we know that there is both a point at which there are no living creatures and at a point at which there are all living creatures that we see today. So thus it makes perfect sense that abiogenesis is directly tied to evolution itself. Because you cannot have evolution just like you cannot have a continuous function that crosses through 0 and 10 and not 4. You cannot have an explanation of evolution that does not include abiogenesis. And yet they all do. They all exclude abiogenesis.
So basically, what you're saying is we have to pass through the point of nothing into something. And the problem is there's nothing at the nothing to something because of the continuous
Yeah.
line.
So let me put it this way. Through another method. Let's say you get pulled over by the police, and you know that you've been speeding, so you know that you have in fact been speeding, and you know that the officer is pulling you over for speeding. And in fact, when the officer pulls you over, he asks you if you know how fast you're going, and you tell the officer that it doesn't make sense that he's asking how fast you're going because at the very current moment you are not going anywhere. The officer is going to roll his eyes at you and maybe even strike you with his baton if he's having a bad day because what you've said makes no logical sense. You've obviously had to traverse. At some point, your vehicle had to have been in motion for your vehicle to have left your house and now parked by the side of the road to get pulled over by a police officer. The officer is only interested in the moment he pulls you over for speeding.
So it's like a hand in cookie jar effect where like I see that the cookie is gone and I see the crumbs on your face, but you are saying, oh, well, obviously I don't have the cookie in my hand.
It's a little, yeah. Yeah, you can describe it like that. But it's instead of saying I don't have the cookie, it's more of saying that it's not relevant that I may have had the cookie because I do not have it anymore. And it's like, well, that's not what we're asking. Obviously, at some point you've had a cookie. The real reason that most scientists do not like to talk about abiogenesis isn't because it's not relevant, it's because it's inconvenient. They don't like to talk about abiogenesis because that's where all of their hypotheses fail to answer the core questions.
So that kind of basically puts a bind on the start of evolution. What about the continuation of evolution after that said point? Is what if some magical thing happens and then all of a sudden, boom, we have life from nothing? What about after that?
As I have heard from evolutionists, they call this something like the eventful equilibrium or a period of equilibrium where things just come together and the proteins just kind of form.
Or what about the common argument that I've heard personally of, well, we've got infinite number of universes with the multiverse theory, and so at some point you will eventually end up with that chance, even though it's so minute that it's nearly impossible.
I see. And this is a argument that is almost seen as powerful by atheists. It's kind of like the argument that they don't think any Christian can realistically answer. Well, the problem is that the theory of multiverse is only a theory. We have no hardcore evidence whatsoever that could suggest any sort of multiverse. And any kind of thing that could possibly explain a multiverse theory is much more realistically explained by just particle physics or quantum mechanics, which in themselves are incredibly advanced topics that are probably too complicated for your average Minecraft player.
Indeed.
But one such way, and that I hear a lot of people try to explain how the multiverse theory could be, is it's a popular argument that actually Stephen Hawking introduces. And Stephen Hawking introduced it in his PhD dissertation. Now, if you ask me, sounds like an awfully miserable thing to do your dissertation on, but nonetheless, Stephen Hawking is a pretty smart guy. And what he does his PhD dissertation over is how singularities, that being essentially a black hole, could have possibly explained the origins of the universe. That meaning a infinitesimally small point, a point so small that it theoretically shouldn't even exist, could explain how the universe seemed to have come from nothing. And so he went off, as I said earlier, brilliantly trying to explain how the singularities could be explanation for the multiverse theory, because every singularity could be a portal, even if actual material can't traverse it. And the problem with his calculations, as genius as they might be, is we know from particle colliders and from several different laboratory experiments that I am not smart enough to properly explain.
Yeah, those are really advanced topics.
And it's idiotic to pretend they're not, right?
Yeah.
The complexity...
Even the complexity of the things we've discussed, there's way more to them than what we've explained.
Yeah. But just the complexity alone of the setup for some of the particle physics that comes to this conclusion is a topic we can't even dabble in here. But nonetheless, they find at things like the CERN and the Large Hadron Collider that whenever the scale of your experiment gets beyond 10 to the negative 32, I believe, centimeters, that is an incredibly small distance. In fact, we call the distance a Planck's or Planck distance. That is the smallest distance known for current physics to actually function. If any experiment should take place in any distance smaller than the Planck distance, then physics as we know it cannot be understood to apply. That seems kind of bizarre, and it is. Welcome to quantum mechanics. Nothing really makes sense anymore. That's kind of the point. But the point of my argument, rather, is that once we get down to a certain distance, that being the Planck's distance, physics as we know it no longer applies. That is, the forces of electromagnetic attraction and gravitational forces and everything are so out of balance, or however, that the equations that we would use for day-to-day physics no longer answer the questions that we seek to ask. So why is this important when we talk about Stephen Hawking's PhD dissertation? Well, he uses physics as we know it to try to describe an event or a singularity that is infinitesimally small. And in doing so is proving that he is by far one of the smartest people on the planet. However, the problem lies in the logic of the math itself. If physics as we know it cannot apply to something that small, then it doesn't make any logical sense to try to use the physics that doesn't work on things smaller than 10 to the negative 2 centimeters on something that is infinitely small. So it's
So it's
It's
like
not that it's a
using
wash.
rules of Monopoly when you're playing a different board game entirely. It's a wholly different set of rules in which gets played.
It's more attuned to trying to use the mechanics that you might use or the physics you might use for a sled race, like a downhill car sled race, to design a hyper performance like track car. The forces are not even close to the same. Now you've got traction that matters. Now you've got, lateral G's, longitudinal G's, all these different factors that don't really play a part in just driving a cart down a hill at 40 miles an hour at the maximum speed.
Mm-hmm.
The physics are no longer remotely even close, so why even bother?
I see. So that was the majority of Stephen Hawking's thing on the multiverse theory. Do you know of any other theories that use the multiverse other than his?
Not off of the top of my head, but again, one of the strongest points that I think most people need to understand is, as I said earlier, it's just a theory. We have no hard evidence that should, my goodness, should suggest that over one theory or the other, that a universe of universes really exists. And I would actually add a philosophical counter argument, not a mathematical counter argument, because I did take differential equations and passed the first time. However, I am not anywhere close to mathematically inclined enough to talk about such a topic mathematically. So if you have a string of multiverses,
Mm-hmm.
then in our universe, why do we only see our universe? If all of
So
the
you're
universes,
going with the because there's an infinite possibility. Why haven't we seen one of those possibilities interact with our possibility?
well, not just that, we have like the Hubble Space Telescope that can tell us the temperature of the entire observable universe. My question is if there has been enough time and enough statistical resources, which there has not, and we can get into that in a second, but if we play the part that they're playing with the devil's advocate, and there has supposedly been enough whatever statistical probability or time or whatever it may have you for all of the events of evolution to happen and for abiogenesis to be irrelevant. Oh, I just realized I placed a window rather stupidly, but that's okay. Then why is it also not true that we haven't had the statistical probability or the statistical chance that one of our universes has collided with another, and we've observed such an event?
Wouldn't we call that black hole?
No, because a black hole is just a concentration of mass. We have no real reason to believe, as far as I am concerned, or as far as I know, I should say, that a couple of universes combining would cause anything even challenging to physics. I don't know that that's even an area of study, if I'm honest with you. Maybe it is, but it would be an incredibly niche area of study. All I seek to say is that we can actively see the observable universe. That's why it's called the observable universe.
Mm-hmm.
And yet we do not observe another universe. And it just seems unlikely to me that we've had all of the time and all the statistical resource, according to evolutionists, for evolution to happen, and yet not another universe to collide with ours or to become visible.
But what
Just
about
think about it.
yeah? But the main issue with that is in the infinity chance, you also have the infinity chance of something not happening.
Explain that.
So if the chance of us never colliding with another universe is a infinitesimally small chance, then in infinity it will end up happening. And what if our chance of this existence is that? So at the same chance rate of us existing, the same chance rate of us never running into another universe. What if we happen to lie in one of those?
Well, I would honestly argue that philosophically speaking, that argument makes no sense because the universes are expanding at an infinite rate. So if you have universes at any distance between each other, there is a 100% guarantee that they will collide.
Hmm.
The only factor is the speed of light. So you mean to tell me that it just so happens that our universe, our observable universe, is far enough from other universes that are either the same age or different ages that we haven't yet had enough time for the light to find the other universe. To me, that just seems a silly idea.
Yeah. So at this point, we've basically talked through all possibilities of it starting. So
Mm-hmm.
now let's go with the continuing. So, as far as we know, the only observable evolution that we've seen is microevolution, or is it macro? I don't remember which one it is.
It's micro.
Micro.
So microevolution being the finch's beak in Darwin's case, growing longer during a drought to be able to get to the harder to reach seeds. Macroevolution being that you get a species change or a phyla change or otherwise a very large change. And in the best way that Stephen Meyer describes this change in his book would be diversity before disparity. I believe this was in Darwin's Doubt. He talks about in classical evolution, as Darwin lays it out, we should expect diversity, that being uh, a creature slowly diversifying from,
So,
you
for
know, well,
example, like the finch, we would see not just the finch's beak, but we would see finch as a species changing from another species.
in macro evolution.
Yeah. So, for example, it would be all the way down to, let's say, for example, reptiles to birds. We don't see that slow evolution process. We only see micro changes in beaks.
And even in the fossil record, we don't see, as Charles Darwin writes, a pretty obvious tree or branching tree of life that comes from one organism, which people like to boast is some sort of sponge, which again, I'm not sure how you come to the conclusion that the first life based off of DNA in living animals is a sponge based on DNA because you don't get fossilized DNA. So I'm not sure how you're supposed to track what creature comes from the DNA without having the DNA of the creature. But
Mm-hmm.
and to help explain as we go on to explain our other arguments why the intelligent design, that is, as Isaac Newton puts it, God being a active governor of the universe, playing an active part in day-to-day occurrences within the universe. The reason why intelligent design seeks to point to something like that isn't just because we believe in God and we love God. That's part of the thing, but we also feel that there are a series of events that become too improbable to explain without intelligent design.
Yeah.
And
So
I can,
I'll wrap up our previous argument real quick.
sure.
So if there's a non-existent, essentially, chance of it coming about um, by chance alone, that requires something outside of the observable universe to cause this observable universe to come about. And that leads into what you were just about to say.
Wait. Oh, okay. Sorry, I'm doing the. I got 16 iron from that. That's a little stupid. Not gonna lie.
Quest system, or the
Yeah.
yeah. Dude, I keep slaughtering all the cows that get in here, and they keep spawning in
Money
randomly.
pouch. How much money did I get? Oh, 20k. Well, that was not worth it. Sorry. So the reason that we like to point to intelligent design is because, it's because of several reasons, but it's not just because a couple of things seem to be rather unlikely, but rather a series of things are stupendously unlikely. So let me explain by using actually Winter Bandit and his career. So as we had explained earlier, Winter, what are the statistical probabilities of getting a pure chance to produce a game such as a Call of Duty?
It is insanely high chance, or like low chance of it happening. So in games, there will be the code that runs the background along with the images and animations, etc. And all of this comes down to ones and zeros. You can basically turn any game into its binary executable file. So for the binary executable for Call of Duty, for example, we would say there's over 200 gigabytes. Each byte is 8 bits, and then so you would take 200 times 8 to get down to gigabits, and then you would take that times 1,000 times another 1,000 to get down to how many number of bits there are. Now, each of those bits can be either 1 or 0. So you're talking about like an insanely large number just for the number of possibilities for each bit to be in. And then you can reorganize each of those bits in any order, which then increases the chance. And by the time you're done with that, it's just improbable that it could just come about by chance.
Do you remember if you ever had a calculable or a number on that figure? It's okay if you didn't.
I did at one point. I could calculate it up real quick. But yeah, I could look that up real quick. Let me go to my calculator. Continue with your statement while I calculate.
Oh, cool. I just got one more chunk. So part of the reason that intelligent design advocates seem to advocate for intelligent design is not just because the formation of our solar system or something similar is so bizarre and so unlikely to happen the way it does. And it's not just because the Earth happens to be in the Goldilocks zone. And it's not just because we have carbon and liquid water and all sorts of other miraculous things that are relatively unlikely, but not statistically impossible within our own universe. One of the main reasons that intelligent design advocates seem to be so sure of intelligent design with science is going into this video game topic, as you'll see in a second. What do you need to play a video game?
You need inputs.
Not just
and
inputs,
outputs.
but you need a place to put the inputs, a way to understand the inputs, a way to understand the outputs, a way to output the outputs. And not only that, but you need access to the internet for most modern games like Call of Duties, and you also need power.
So the
And
chance, just got the results back. So the
yep,
probability of a Call of Duty game happening is 1 in 2 to the 1.6 trillion.
yeah.
And that's being very generous because every bit must be exactly correct and it has to be compiled and perfectly compiled and no errors. It is absolutely insane.
And again, going into this explanation of intelligent design, which conveniently needed to happen after that statistic. So not only is that single statistic pretty outstandingly powerful by itself, but similar to proteins or DNAs in living cells, simply having the protein in the living cell or having the DNA for a living cell does not explain how the living cell came to be in the first place or how life came to be in the first place. Because let's say you did make all of those massive statistical chances happen and now you have a real playable video game, but it's on a CD player and you're in a dead blank universe. You still can't play Call of Duty. You don't have a controller, you don't have the internet, you don't have power, you don't have a Xbox, a PlayStation, or whatever you might have. You don't have an HDMI cable, you don't have a fiber optic, you don't have speakers. All of these things work together for a single common cause, that is, you get to play Call of Duty.
And then on top of that,
Similarly,
you also need
go ahead.
all of the other players in the Call of Duty world, which are also complex beings.
Yeah. So, similar to that, intelligent design notes how there are several improbable events that all work together to result in life on Earth, intelligent life on Earth being possible. And to explain why that's so important and maybe what I mean by all of this complex talk, scientists in the 1900s were trying to figure out how carbon comes into existence. So carbon has an atomic weight of 12, that meaning that it has 6 neutrons and 6 protons. And there's an even more complex set of requirements that have to be met because of up quarks and down quarks, but that's an argument for another time. The main point I'm trying to make here is known as the carbon resonance problem. And that's a complicated subject, so I'll try my best to explain it in layman's terms. But essentially, there is a gap called the 5 nucleoid gap, which sounds complex or something you might hear in Star Trek, but all it's trying to say is that when atoms or elementary atoms get to a nucleus size of 5, that meaning they have 5 protons or 5 neutrons or 2 protons and 3 neutrons, whatever you may have. The problem then becomes the half-life of these molecules are fractions of a fraction of a fraction of a second. Their half-life times are unbelievably brief. And so scientists then began to scratch their heads.
So the half-life is how long they stay before they rotate back to a different atom type.
So yeah, think of it this way. The best explanation of half-lives that people seem to be more than familiar with is uranium. If uranium has a half-life of 104,000 years, that means that after 104,000 years, half of the uranium will have deteriorated into lead or strontium 120 or strontium 190 or whatever uranium actually goes into. So that means at twice the half-life, you're going to have a fourth of the uranium left. And at 16 times the half-life, you're going to have 32, 1/32 of the uranium. You're never going to have exactly 0 mathematically, but practically you very well do have values of 0. And even if they're not values of 0, they're in no way, shape, or form useful amounts. And there's a whole nother aspect of half-life degradations and stuff when you talk about biology, but just talking about the carbon resonance problem here is so scientists figure that the only way we can get carbon to form is in stars, because you don't get planets and you don't get life really at all without carbon. And no, there is no silicon-based life. That is not even, it's hard to explain, but carbon has an affinity not only for water, but carbon has an affinity for hydrogen and sulfur. Carbon is the perfect element.
It likes to
Silicon
attach itself
really,
to everything.
silicon is not, like if you were to ask any actual biologist what silicon life would look like, they would tell you that it doesn't look like, because it's not possible. It's not an actual serious thought in the scientific community, right? So we know that carbon is required for life as we know it, and yet we can't seem to find in the 1900s where carbon comes from. And it's confusing to scientists, because if the universe is full of carbon, then it mustn't be impossible for carbon to form. And there's a complex set of requirements in thermodynamics that we know that are laws of the universe. One that is fairly widely known is that matter nor energy can be created or destroyed. And what that really means in a practical sense is that you can't have two things that combine that have a higher energy than the result, because you need a beta particle to be emitted or a photon to be emitted. Something needs to happen so that the energy levels are conserved and that the total energy level is maintained, and the change of the system is zero. And the problem here is that in all of the experiments that the scientists were doing, they found that the only way possible they could get carbon to form in a star situation would be if you had beryllium and helium, because beryllium has an atomic weight of 4, and helium helium-4 having an atomic weight of 4, you get the 12 that you need for carbon. But the problem is even beryllium, being an atomic weight of 8, has an incredibly short half-life. But still, nonetheless, there is no other feasible way that we know that carbon should exist. So the scientists went on to do their laboratory experiments, and through some incredible genius and scientific discovery, he had discovered that there is a, we observed the carbon happening, but at the time, they couldn't find a way possible in a lab for carbon to form. And then the gentleman had a profound implication that the reason why he can't get carbon to form is because he's trying to violate one of the laws of thermodynamics, and that energy cannot be created or destroyed. Understanding this, he then realized that there must be a higher energization state, that is a charged or above ground state of carbon that exists, that humans have never actually seen before, because it only exists in this extremely rare case in stars. And upon doing so, he calculated that it should be possible, and then they spent several years trying to find the setup and trying to actually get it to happen, and eventually he could find it to happen. But he found that it only happened whenever the system had the exact resonance, that is a special frequency or an energy state, an excitation state, that makes it possible for those two to combine. That is your resonance. And resonance is at that time was a brand new quantum theory concept, and that was one of the first ways that they were able to actually prove that resonances were in fact real. And why this is a problem is because you're effectively coming to the conclusion that carbon is extremely unlikely an event to form, but yet does so all of the time. And that's important for more than one reason. It's not just because there are enough stars, right? So in order to have this excitation state, this energy, where do you get energy from in a star like our sun? You get it from heat. So what controls the thermometer in the sun? It's not your grandma complaining that it's too cold. It's instead, it's the mass of the sun and the gravitational field of the sun are quite literally pulling things together so strongly that the helium has an interaction with other elements, such as beryllium, and that reaction releases heat, and you get these heat of the sun. And if that heat is just so, it becomes possible for the carbon resonance to be fulfilled. But the problem is, it must be just so. And if that was on its own, and the heat of our sun just needed to be a certain level, then that would be fine. However, there's a certain concept tied to the entire universe that determines the average temperature of most stars. That concept is known as entropy. Now, entropy sounds like something you might hear out of thermodynamics class, or something that might be scary, but really all entropy means is that stuff scatters, right? So if you spill your cup of milk in the living room, it doesn't just magically climb back into the cup. The entropy is wanting to go from a low state of entropy to a high state of entropy, meaning the milk is going to soak into the rug and get into the floorboards and just go everywhere. The order of the system, that is the milk sitting in the cup, is going to reduce over time unless energy is used or energy is spent. Like your fridge uses energy to keep the entropy of the fridge low. That means you're keeping all of the fridge inside at a constant temperature below atmospheric. But
Keeping
to
things from
explain
going
why this
bad.
matters,
Spoilage is basically what you're saying. So entropy is spoilage of sorts.
Entropy is more like the gremlin, if you will, that seeks to cause chaos in the universe, is a good way to explain it. Like entropy is that everything just becomes undone. Every stack of rocks you're going to leave on the mountain is eventually going to be reduced to dust in the wind. Nothing will ever remain where or as it is.
So then, wouldn't that also call back to why do we think evolution builds instead of entropying down? Because it would seem to me that for life forms to form, you would have to combat entropy.
And that is a great question, and I will get to that in a second because I'm approaching the finality of the carbon resonance here. So entropy also controls stars, not hard control, but more of a soft control. So our sun, if entropy was any lower, by fractions of a fraction of a fraction of a fraction, would be a black hole. The star could have never formed in the first place because the hydrogen simply would have collapsed too fast, and the weight of the sun would have been bearing down on a growing infinitesimally small point, and then eventually you would end up with the singularity, and no stars in the universe would be possible at all. And if the entropy were any higher, the hydrogen wouldn't have the ability to combine into a star in the first place, and you would never get any stars. That's not to mention that because of the absolutely perfected, fine-tuned aspect of entropy, you get stars that produce carbon. So that's one of the first multitude of aspects that intelligent designers point to, is just that it's such an outstandingly unbelievable event to have occurred by chance that not only is the entropy in the universe so that we actually do have stars in the first place, but we have stars that generate carbon necessary for life. And going back to your question, which is a very good question, and a question that I think more people should be asking. Entropy in the universe, in just about every way that is practical, reduces the order in a system to just chaos. That doesn't mean it always happens that way, but that just means that that's the overall thing that happens. So as you get mixtures or things that form in a biological soup per se, what happens is entropy takes over, and now all these things become spread out from one way or another.
So it'd be like,
And now,
here, I'll give a good example. So it'd be like if we were to
sure.
mix a bunch of paint together. It's going to end up a brown mushy mess rather than separating into perfectly separated colors like blue and red and all the primaries. Like it's
So
really just going to turn into a brown soup.
let me explain it in a way that makes more sense, because you could say that you are attempting to get a brown soup, right? And it's a predictable result. So let me explain it in a different way. So now let's imagine you want to make the Millennium Falcon out of Legos, and you have a random, non-specific kit of Legos. It is not the kit designed to produce the Millennium Falcon, right? Just as we do not have a planet, unless you believe in intelligent design, that is designed to generate intelligent life. So you get a random kit of Legos and you throw them over a cliff into the Pacific Ocean, and you wait 100 years and you come back expecting a Millennium Falcon to be already assembled. Well, as anybody could tell you, that's not what's going to really happen. What's going to happen is you're never ever going to see those Legos again, because entropy would ensure that they all get scattered amongst the infinite expanse, the practically infinite expanse in this scenario of the ocean. Similar would be organic particles as they start to form, would not get the chance to interact with each other.
And then even then, the Legos would dissolve into nothingness or get bleached beyond
Yeah,
use.
beyond.
They would
Yeah,
turn to
and then
dust.
similar things happen at a much quicker rate when it comes to living organisms, because as I was saying, the half-life of most of these compounds is fractions of seconds or fractions of minutes, and so the adding of time actually works against life. It's not that you get more statistical probability, and that's a good thing. It's that actually you get more time for entropy to spread things further apart. And now the chance of them actually interacting with each other becomes infinitesimally small and becomes effectively a new way to calculate zero. Just like you're saying with the Legos, right?
Mm-hmm.
Over time, they're going to degrade, dissolve in the water, and the colors are going to be unrecognizable. The same thing happens with compounds of life.
Indeed.
We'll let some of my chickens out into here.
The chicken slaughter.
Yeah. Oh, that's a. You guys don't know the mistake you just made.
They just try to escape.
Oh, I probably killed more than that too. That's okay. I have way too many of these guys, anyways. Ah, oh, you've managed to escape. That's okay. Do you need? I'm telling you, bro. If you need eggs, I've flipping got eggs.
Enough eggs to last a century.
I almost have a double stacked chest of eggs.
Well, what topic shall we move on to?
So, another really clever aspect that I believe was brought up in Darwin's Signature of this in the Cell by Stephen Meyer
Oh yeah,
is
I've heard of that one.
a lot of people like to say that there are enough possibilities in the universe for life to have formed just by chance. So
Here, real
let me,
quick, I'm gonna interrupt you.
yeah.
This section, you want me to flatten it down to that level?
Huh?
You want me to take this section down to the level down there, and then we can make like a
No,
fancy courtyard?
I mean, you can bring it down like to this level, But any lower and you're going to ruin my entrance.
See. You know what? I'll do a rounded shape here. Like, I'll bring this corner in a bit. And just kind of do a rounded shape here. Because I'm thinking of a fancy courtyard down the bottom there with like fountains and...
Wanted to go well with the fountains on my hill and everything.
Yeah. And then have fancy paths around in a garden kind of section.
I've forgotten what I was going to talk about.
Stephen Meyer, something.
Ah, thank you. So, people like to say that there is enough chance for life to have just suddenly evolved on its own, even if you ignore that life as we know it, just randomly forming, actually prefers less time over more time, because these organic molecules quickly dissipate or quickly attach to sugars, because proteins and stuff like DNA much would rather form with sugars and just irrelevant phosphates than it would bond to the things that you would actually want it to bond to.
Basically, it's very difficult to get the things to merge together because they want to merge with everything else. And you need a specific scientist to assemble them on purpose, as one would say.
So one might say an intelligent interventionist or an intelligent designer. So there is a means of which we can actually calculate an incredibly optimistic maximum amount of statistical resources. That is the amount of time and the amount of events ever possible in the universe. And we can calculate it as follows. So there are 10 to the 80 elementary particles in the observable universe. That is all of the objects that have ever been to interact with each other.
And what do you mean by particle?
So like a singular carbon or a singular helium or a singular elementary particle. Not necessarily, kind of, but they're elements. So it's not like a compound or a covalent bond. That's why elementary matters. Because you could have a particle that is consistent of multiple elementary particles. But all of the elementary particles in the universe is 10 to the 80. And then you take the Planck's distance, which is the smallest distance between any two things that we know could be physically affecting each other. So you then take the speed of light, which is the fastest speed at which any object can actually travel in the universe as we know it. So now you have all these factors together, and you have the maximum amount of particles ever to exist in the universe. You have the fastest speed ever observed in the universe, and you also have the smallest distance ever known in the universe. And you multiply and divide all these values together, and the number that you come up with is 10 to the 240. That number means that there are 10 to the power of 240 possible events ever to have occurred within the entirety of the history of the universe. And the reason that this matters is because if you get a statistic that says, I don't know, that is for a single chain of proteins is 10 to the 14,000 that it should ever change, that statistic is then equivocally 0% chance possible, because it is significantly, like orders of magnitude, several unfathomable orders of magnitude larger than the maximum number of possible events within the entire universe as we know it. So it therefore does not make any logical sense to suggest that there is enough statistical resource and enough time of the universe, or that the universe is big enough that things like this can happen, because it mathematically is not big enough.
I see. Brain's also occupied by placing blocks.
It's funny how little changes between ages 4 and 20 something.
Yeah. Yeah.
The only difference is now I'm not in a real mine.
Indeed, I'm no longer digging in the dirt. I'm digging in the dirt virtually.
Yep. I'm no longer planting trees in the real world. I'm now planting trees not in the real world. I'm also no longer cutting down trees in the real world. You know? Do I have a claim? I think I used the claim to get that one little spot that was like in between the two of our lands.
Yeah, I'm gonna see if I
No.
can. Alright, I got this one I'm standing in.
Nuh-uh. Am I suddenly entering over here? Yes. Make sure it's continuous before I spin this one last one.
People are gonna scrub the video and they're gonna be like, he's still digging this out.
Yeah.
This whole time he's done nothing but dig out this giant area.
Oh. How did that kill me? Where did the server reset?
Oh, you died. You blew up to a creeper.
Yeah, because it. I told you that the lag would be the death of me.
Luckily, we're not on hardcore. So have you done any research into near-death experiences? Oh, did we lose him? We lost him. He DC'd. No.
I'm bad.
Oh, he's back.
Lost connection to server.
I see. I was like, he's gone.
Invalid session.
Can you not rejoin?
I'm gonna try closing and reopening. The game crashed.
I think your internet crashed for a second there, too.
No. It has to install something.
Oh, cave. Every time I dig anywhere around here, it's just cave.
I know. Good thing you picked terrible land for caves.
I know, right? Somebody said something about me picking terrible land for caves.
I don't know. That's kind of, it was a little while ago. I can't quite remember. Yeah. Try restarting your game and the launcher.
Let's see here. Have you done any research into near-death experiences?
Not a particular amount.
There's quite a bit of research done into this. You know, it's the same guy who did the Case for Christ. What was his name? I don't remember his name. Give me a couple seconds, I'll look it up. We shall find out. Two. Oh, what was this one? I'm looking it up.
Ladies and gentlemen, this stream is brought to you by Awkward Silence.
Oh, that's good. Awkward silence. Indeed. While I try to look up the name of this author, my brain is shorting out. You know what? We'll jump into a different topic. What do you think? What topic shall we do now? How do you know that your religion is the religion and not, let's say, for example, Islam or Buddhism or...
Good question. So, what is one thing in common with nearly every religion? They all have...
Other than atheism, a god.
Well, not just a god and a devil, but a flood. Nearly every religion on the planet starts with some kind of folklore of a flood. So why would that be?
Well, they're all the same religion in the end, aren't they?
Not necessarily. Islam and Judeo-Christian beliefs have some similarities, but they really seek to do quite different things. The Quran is really not in any way, shape, or form the Bible.
They claim to have, well, their basic gist is they have the Torah, or the first 5 books of the Bible, along with the following few books of the Bible, I believe. And then they also say that they take the Gospels as part of their tradition book, etc. And then the Quran was written after that as the successor to those, so it'd be the sequel, so to say.
Yeah.
The problem with that is, in the same book, it claims that some of the writings that came before, there was issues in them, and that need to be corrected by the Quran. Same thing as when it says that Jesus was not God, even though he claimed to be God, or God's son in this case, because in the Christian belief,
Son of Man.
Yeah. So,
well, even if you don't believe, real quick, even if you don't believe that Jesus had ever said anything close to that he was God and that he's just a prophet, well, the prophet of Isaiah is pretty clear about that.
Indeed, there's so many prophecies about Jesus that it's an overwhelming amount. And then the Jewish tradition, there's it kind of like splits there, depending on who you talk to, where some believe that Jesus was a fake, so to say, kind of like in Jesus's time, there was a bunch of people claiming he was a fake. And so there's still people that have that presumption. They're still, quote, waiting for the Messiah. And then,
which is funny because those are the same people that would believe in an Antichrist, as portrayed by Revelation.
Mm-hmm. So continue your thought. You had floods thing.
Mm. So not only do all religions have flood, but no religion on earth is as well documented and as well confirmed as Christianity. So if you have the destruction of Sodom and Gomorrah, right? The two cities that were magnificently and horribly destroyed by the God, the Creator. And to also add a little bit of understanding into how Christianity works, it seems to be something that even most Christians don't seem to understand, is God is not just a nice guy. He also, I wouldn't even say has an anger problem, but it wouldn't be that much of an understatement.
It wouldn't be even an anger thing. It's the people there were doing unspeakably awful things.
Yeah.
Because God has two features to him. He's both just and loving. And what a lot of people forget about is the just part. So let's say, for example, you're a parent and you have two kids. One kid beats up and bullies the other kid. In order to be just in that situation, you need to punish the one doing the bullying and the beating up. And to be loving, you have to protect the
Consult.
one, yeah, the one getting beat up, and also to not over punish or to unjustly punish. So there's so many nuances to it, and things that people miss. Where am I trying to get at? My brain's fizzling.
Well, that God can be both punishing and forgiving.
Yes, yes. So with Sodom and Gomorrah, in that particular circumstance, he gave them an insane amount of time to change their ways. And also in the book, Abraham is trying to save Sodom and Gomorrah by saying, if there's only this many people that are still good, if there's only this
there's
many
only
people,
3.
yeah, and it came down to like just Lot and his family, and not even that happened. Like, it was so bad.
Well, and again, as the point you just hit, is it says clearly in the Bible that it's not just that God arbitrarily destroyed this town because these people were sinful. It's because God had given them a extraordinary length of time and a lot of hints that were arguably pretty obvious.
It wasn't
to
even just
say
hints, it
you
was
are,
just straight up just like, hey, you're not doing.
yeah,
Yeah, it was.
it's just
They were doing
a
awful
series of
stuff. Like, there was women there that were getting absolutely. It was terrible. Like the things they did to people were just awful. Like, it's the people we send to the death penalty in the United States kind of thing. Like, it's not anywhere near, like.
Well, depending on the district attorney, but yeah.
Yeah.
In California, they just let them run.
That would be getting into politics here. So back
Does
to
it
your.
count as getting into politics if you can
True.
literally like look it up and it's like 90% of all cases? Like, is it an opinion if it's provable by fact?
True.
But yeah.
All right, so back to your thing on Sodom and Gomorrah.
Yes. So in the early 2000s, it had actually been discovered that there's actually a cross reference from a non-Christian source in India when he talks about a date and a time that would make sense for the simultaneous occurrence of the destruction of Sodom and Gomorrah, that he saw essentially hell and fire raining down from the skies, and he had described the directions of the meteor that had hit the atmosphere and exploded into a fury of fire in a way that would describe the directions of Sodom and Gomorrah. So not only are the events very well documented in the Bible, but they're very well documented outside of the Bible.
And like, for example, another one would be the Dead Sea Scrolls, or for
Hmm.
example, all of the historical evidence of Jesus existing and his death and resurrection. Like there's over 400 witnesses of that, and we have
Yeah.
witness testimonies from non-Christian sources like the Roman writers and historians.
Hmm. It's also key to note that the very people that are recording these events are recording them to essentially bring Jesus down. They understand that in their system of bear no false witness, that if one of them were to lie once, their entire case against Jesus would disappear. That's why they were trying to catch Jesus in his own words and have scribes writing things down furiously to try to catch Jesus in saying something that might look bad, so that they could use the Romans to enforce Jewish law, which was already a no-no.
Yeah, and then you have people following him around, keeping notes of everything he's saying. You have a lot of these parables and sayings that are repeated over and over and over orally, and then also written down like less than 100 years later. So the people that first heard it would have been keeping notes.
Yeah.
And they've been traveling with the guy for like decades of hearing the same story over and over and over.
Jeez.
So it'd be very similar to memorizing a song nowadays, where you could remember every single word of a song and be able to like say it back years and years later. And then on top of that, all of your friends also memorized that same song over and over
Yeah.
and over. And then you're all cross-referencing with each other. And in testimonies, you would also have different views of the situation. So, like, let's say I was standing on the balcony, or the pilot man over here standing on the ground. We would have different viewpoints of that same circumstance. We also have that same difference in view in our testimonies that we have. So it's not just a carbon copy of each other where you might think of collusion or some sort of narrative they're trying to spin up. And then also, they were getting murdered and tortured and all kinds of nasty stuff to try to get them to renounce anything they were saying, which, you know,
Mhm.
no normal person would hang on to their beliefs to, you know, burning at the stake or getting crucified on a cross upside
And it
down.
became an actual crime to say with your own words that Jesus was the Messiah. Like, it became a crime in Israel from the synagogue. So that even if Jesus were to say that he was the Messiah, it would be considerable a very harsh crime of like public stoning and public beating.
Yeah, it would not be something you would do just to like jump on the bandwagon of what's the most popular
No,
thing of the day. No, no, they were staking their lives in that.
this wasn't. It's not something that these people were doing because of some weird clout or some popular thing. It was something that they believed in enough to put their own families and lives at risk. And not only that, these people believed in Jesus enough to throw their own lives away. How many people today could meet you at your job, if you're like me, in a mall or something, and just straight up tell you, quit your job, stop going to college, and follow me?
Yeah.
how many people could actually get you to do that?
I would say not very
Even
many.
as a Christian. And the other thing that I think is a really bad, what's the word? Placation or whatever of the Jesus case is confirmation bias. People like to say, well, oh, they've been waiting for the Messiah or whatever. Now a guy comes calling himself the Messiah. It shouldn't surprise anybody that he becomes the Messiah, like understood Messiah of Israel. But the problem with that is that how at all is the timing perfect if the synagogue is trying to kill Jesus for simply saying he is the Messiah? Like, it's probably one of the worst times in history for Jesus to try to claim he was the Messiah. That's kind of the point of him being at that time in history. There were so many other people that had come before him claiming to be a false a Messiah and being a false Messiah.
Yeah, and there was a bunch of other people like also claiming that at the same time as Jesus.
Oh yeah.
Yeah, it wasn't just like him claiming it. Let's see, what shall our next topic be? I mean, that could wrap it up for today. Could come back to it another day. I think we'll end it here for the day. I think we'll come back to this again another day. Thanks for hanging out for this hour-and-a-half long lecture of two people playing Minecraft.
Of course, if you have any questions or even criticisms of some of the things brought up or introduced in this video, feel free to comment about them or feel free to talk about them in the next stream.
Indeed. Can't promise anything about the time for the next stream, but yeah. Have a good day.